Okay, we have a double integral, and in the directions they say reverse the order. It's because of the integrand that we can't start this as a dy integral. We can't find the antiderivative of 7 over y cubed plus 1. And so we have to reverse the order. We have to do it as a dx dy integral. Let's figure out what the region is. We have y's between, on the low end, root x, and on the high end, 3. X is between, on the low end, 0, and on the high end, 9. And so we need the curve y equals root x. That's the only mystery of those guys, what they would look like. And y equals root x. It's just going to be curved like this. That's the low end, y equals root x. The high end is y equals 3. That's just going to be a vertical line, I mean horizontal line. Y equals 3. And then we have, they're doing it as dy dx, and we want to do it as dx dy. Let me draw both pictures here. Dy dx is a rectangle that is vertical, that you move horizontally. We have we cover up the region by moving a vertical rectangle horizontally. Well, when we switch to do it as dx dy, then we flip that and we do a horizontal rectangle and move it vertically. That's what this is going to be down here, dx dy. And so we have a horizontal rectangle moved vertically. That would be this. Now, what would be the bounds on x? We find the lowest x ever is and the highest x ever is. And then we move that from the lowest y ever is to the highest y ever is. So this translates into x is between, on the low end, 0, and on the high end, we're on that curve. Now this curve up here was defined as y equals the square root of x. It still is this down here, but we needed x equals the square x equals y squared, so that and everything's in terms of x. So 0 to y squared, and then y's go between, before they were up at this high point of 3. Same thing, we're going to go from 0 to 3. Okay, great. So we have the integral from 0 to y squared, the integral from 0 to 3, and that's supposed to remedy the situation because the integrand is all in terms of x. It's 7 over y cubed plus 1. That's all in terms of there's no x's in that. And so when we integrate with respect to x, we just get exactly that integrand times x. And so we get 7 over y cubed plus 1. All of that times x, evaluated from 0 to y squared. So basically we just get a y squared in there, and that's what we need to be able to do our substitution. And other than this, we have this outside integral in terms of y from 0 to 3. So we're going to have 7y squared. We put in the y squared, put in the 0. So that just becomes a single variable integral from 0 to 3, 7y squared over y cubed plus 1. dy. We'll do a u substitution. Let's see where I want to do with this. Okay, we're going to do a u substitution. Let u be the entire denominator. If I was to let u be y cubed plus 1, then du is going to be 3y squared dy, and we need to get rid of y squared dy. The 7 can just come out. In fact, let me just do that. Take this 7 out of here and move it in front. So we need to get rid of y squared dy, so we need another factor. It's going to be 1/3. Du is going to take the place of y squared dy. So we'll have 1/3 the integral 1 over u du. So that's 1/3 the natural log of u. Okay, so we'll have 7/3 the natural log. Officially it should be absolute values, but I'm going to go ahead and say y cubed plus 1 in parentheses, seeing how the limits being 0 and 3 help us avoid negatives. And we'll be done. We have 7/3 times the natural log of 28. Right, 27 plus 1, yeah, 28, minus the natural log of 1. Right, 0 cubed plus 1. Natural log of 1 is 0. So it looks like the answer is 7/3 the natural log of 28. This right here is just a u substitution that we worked out. Oops.